Do you find yourself in the same position as just about everybody else when it comes to wondering the truth about Nemesis and Nibiru? Do you find yourself thinking, if it were really true, one of the many NASA scientists or some other space-aimed telescope facility would come forward and tell you the truth? Remember this during your next search. It's not what they are telling you, but what they are not telling you that should concern you. Have they found any brown dwarf stars at all? If Nemesis did possibly exist, and they didn't want you to know about it, wouldn't the next question be, how can they hide finding it to the public? Maybe by calling it by another name.
When I got the news on April 23rd, earlier this year, that a flare had been detected by SWIFT, and it was coming from a nearby flare star called DGCVN, I was initially very surprised. SWIFT doesn't normally detect flares from nearby flare stars, and DGCVN is a relatively unknown star.
There are a few things we know about DGCVN. It is an M-class star, also called a red dwarf, and is located only about 60 light-years away.
It's a dim little red star. It has a luminosity that's about 1,000th the luminosity of the Sun. It has a mass that's about 1/3 the mass of the Sun, and a radius that's about 1/3 the radius of the Sun.
The largest solar flare ever recorded happened on November 4th, 2003. It was so powerful that it overloaded the sensors measuring it, but later calculations put it at an X45. Flares are classified according to their strength. The smallest ones are B class, followed by C, M, and X, the largest. An X45 flare is a very powerful flare. DGCVN's flare, however, was much larger.
We can estimate how big the flare on DGCVN was with respect to the solar scale. It would have been an X100,000. So this is several orders of magnitude larger than the biggest solar flare we've ever seen. The flare that SWIFT triggered on from DGCVN was only the beginning of what turned out to be a fairly extended series of flares, a flare event, if you will, that lasted almost 20 days.
This was a very different star than the Sun, so we don't really have to worry about this happening in the present-day Sun. The young Sun, such large events may have occurred. In the present-day Sun, the activity levels are much lower. And the fundamental reason that DGCVN is more active in the Sun is it's a very young star, 30 million years. It's rapidly rotating. Young stars are born that way. And rapid rotation is one of the key ingredients which powers activity. The faster the rotation, the greater the activity.
While not a threat to us, the massive flares of red dwarf stars can help us better understand the flares produced by our own Sun. They are also of interest because red dwarf stars are often orbited by planets. Some data suggest that 40% of red dwarfs have super-Earth-type planets orbiting in a habitable zone, where liquid water is possible. If this is true, then they are good candidates for supporting life. However, the habitable zone around a cool, dim star like DGCVN is much closer to the star than the Earth is to the Sun.
When planets are closer to their star, they're more susceptible to anything the star does. For instance, if the star flares, the planet is much closer to the star and it can be hit by the radiation or the particles that get ejected from the star when this flare process happens. If you happened to be on a planet around an M dwarf when one of these large flares went off, you'd be having a very bad day.
What the fuck?